Hello friends, welcome to my YouTube channel, Pro Mathematics Academy. So today we are looking into this integral. This an interesting integral. Please, before I start, don't forget to subscribe to my channel. Don't forget to like videos. Don't forget to share my videos to your friends who also like mathematics. So God bless you all. So solution. Okay, so let me call this integral JV. Yeah, I like letter J very well. So J is equal to integral running from 0 to infinity of dx over x raised to the power 4 minus a squared plus 1. Okay, so I can say let x be equal to 1 over x. So I say let x is equal to 1 over x. Then I find my dx. So dx will be equal to minus 1 over x squared dx. So that was my dx. Dx is equal to minus 1 over x squared dx. So I cannot write my integral. Okay, don't forget that the limit will change. So when x tends to infinity, so the limit here will be 0. 1 over infinity is 0. And when x tends to 0, the limit here will be infinity. That is 1 over 0 give you infinity. Then you have ja is equal to negative, this is a negative here, integral running from infinity to 0. Now your dx is now 1 over x squared. So I have dx all over x squared into brackets. Now your x is now 1 over x. So you have 1 over x raised to the power of 4 minus a into brackets 1 over x raised to the power of 2 plus 1. Now, let me quickly tell you something. If you have negative integral running from a to b of f of x dx, so this will give you integral running from b to a of f of x dx. That is, this negative sign will make this limit to change. This b will come down, this a will come up. So that's what we are going to do here. This negative sign will make our limit to change. Then I have integral ja equals integral running from 0 to infinity of dx over x squared into bracket. Now that will be 1 over x raised to the power of 4 minus a over x squared plus 1. So if I use this x squared to open the bracket here, okay, so if I use this x squared to open the bracket here, I have is equal to integral running from 0 to infinity of dx over, so x squared next for that is 1 over x squared minus a plus x squared. So don't forget that the same here will be x squared. Then I have ja is equal to integral running from 0 to infinity of dx all over, so the same here is x squared, and I have 1 minus ax squared plus x raised to the power of 4. So this is equal to integral running from 0 to infinity, so it will reciprocate, x squared will come up, and I have x squared over x raised to the power of 4 minus ax squared plus 1 dx. Okay, let me move to the next part here. Now don't forget that if you factorize this, x squared over x raised to the power of 4 minus ax squared plus 1 is the same thing as 1 over x minus 1 over x squared plus 2 minus a. Okay, let me prove this for you guys. Don't forget that x minus 1 over x squared will give us x minus 1 over x multiplied by x minus 1 over x. So you have x squared minus 1 plus 1 over x squared is equal to x squared plus 1 over x squared minus 2. So let's add it to these two minus a.
Yes, oh yeah.
Then I have x squared plus 1 over x squared minus 2 plus 2 minus a. You can see This and this cancel each other. Then I have s squared plus 1 over s squared minus a. So then I have 1 over s squared plus 1 over s squared minus a. So you have your LCM here. The LCM will be x squared, or you can see we have this our original integral here. Are you getting what I'm saying? So if you factorize this, you get this. So that is it. So if you try to take the LCM, you have 1 over s squared. So that would be x raised to power 4 minus as squared plus 1. So s squared come here, so you have s squared over x raised to power 4 minus as squared plus 1. So we have our original integral here. Or you can factorize it from this angle here. So you can factorize it anyhow you want to do it. So this is how I want to do my own. Okay, then I have JA is equal to integral running from 0 to infinity of dx over x minus 1 over x squared plus 2 minus a. Now, let me recall something for you guys. Don't forget that integral running from negative infinity to positive infinity of f of x dx, it will give you 2 multiplied by integral running from 0 to infinity of f of x dx. Then you can say that integral running from 0 to infinity of f of x dx is the same thing as 1 all over 2 integral running from negative infinity to infinity of f of x dx. So therefore, I can rewrite this integral in this form. Here is my f of x. Are you getting me now? Then I have ja is equal to 1 over 2 multiplied by integral running from negative infinity to positive infinity of dx all over x minus 1 over s squared plus 2 minus a. Now, I'll be recalling something now. We call it Glazer's master theorem. Glazer's master theorem. So if you have an integrable function, you have integral. So here is the theorem. Integral running from negative infinity to positive infinity of f into brackets x minus 1 over x dx is the same thing as integral running from negative, okay, s will be here. So it's the same thing as integral running from negative infinity to infinity of f of x dx, where s is greater than 0. So s is a constant here, so where s is greater than 0. So that's what we are using here. Then you can now say this your x minus 1 over x. So this will definitely be x using the Glazer's master theorem. So then I have my JA is equal to 1 over 2 integral running from negative infinity to infinity of dx over s squared plus 2 minus e. So our work is now beautiful. So just use the basic integral for the tan of x. Don't forget that integral of dx over s squared plus b squared is equal to 1 over b multiplied by arctan of x over b plus c. So that is one of the basic integral. So you are going to use here. So I have to manipulate this so that to give me square. So I have 1 over 2 integral running from negative infinity to positive infinity of dx over a squared plus root of 2 minus a squared. So root 2 minus a squared will just give me 2 minus a. So that is it. We are doing the same thing. So use the above formula there. Then I have ja is equal to 1 over 2 integral running from negative infinity to positive infinity of dx all over s squared plus root 2 minus a squared is equal to 1 over 2 multiplied by, so here's my b, 1 over square root of 2 minus a multiplied by arctan of x all over square root of 2 minus a. So you apply your limits running from negative infinity to positive infinity. So I have ja is now equal to 1 over 2 into bracket 1 over square root of 2 minus a. So you can make down to a bracket like this. So infinity will be here. So you have arctan of infinity minus arctan of negative infinity. Now, don't forget that arctan of infinity minus arctan of negative infinity will give you pi. This is what I'm saying. Arctan of infinity is equal to pi over 2. Arctan of negative infinity is equal to minus pi over 2. So arctan of infinity minus arctan of negative infinity is equal to pi over 2 minus pi over 2. So minus times minus give us plus. I have pi over 2 plus pi over 2, which is give me pi. So here is now pi. So I have ja is equal to 1 over 2 multiplied by square root of 2 minus a multiplied by pi. So 1 times pi will give us pi. So I have pi all over 2 square root of 2 minus e. So here is the answer to this problem. So I'm sure you understand this video and you like this video. So if you like this kind of video, please don't forget to subscribe to my channel. Don't forget to like my video. So don't forget to like my videos. And don't forget to share my videos to your friends who like mathematics. So thank you to you. Thank you.